Today we're going to be talking about section 7-9, which are exterior angles. So exterior angles are pretty much exactly what they sound like. Exterior meaning on the outside, but we're still talking about angles. So an exterior angle, if we just get a definition here, is going to be an angle created when one side of a figure is extended. So it is extended. Sorry. Okay, so we're extending a side. So I'm taking one side, if we look at my picture here of this triangle, and I'm extending it out to the left here. Okay, by doing that, I'm creating this new angle on the outside. So angle BAD is an example of my exterior angle. Okay, now there's a theorem that goes along with that exterior angle, in particular for triangles, is if I think about my angles that are created on the inside here. So I have angle B, I have angle C, and I have angle A. Okay, angles A, B, and C all have to add up to be 180. Okay, but what happens is I can get rid of this angle in the middle. Okay, angle A, and I now have two angles that are left. Those two angles plus the one I'm covering up have to add up to be 180. And then if I look on the other side, this angle, okay, my exterior angle plus my angle A, also have to add up to be 180. So if I take that same measurement out of both of those, I'm taking the same amount away from 180. So what happens is this angle on the outside has to equal my two angles on the inside added together. And that's really what the exterior angle theorem says. It says in a triangle, the measure of the exterior angle is the sum of the two interior angles opposite the exterior angle, meaning that I'm using the two angles that are not immediately adjacent to that exterior angle. So I couldn't use angle A, but I can use angle B and angle C. Okay, so let's go ahead and give this a shot. If I go down here to number 1, I want to give the measure of angle BAD. It's the same picture we were just looking at, where angle B is 49 and angle C is 53. So this is 49, this is 53. Now, I could go through, I can add these together, subtract it from 180, find angle A, then take angle A, subtract it from 180, and get angle BAD. But I can do this a little bit faster now. I can take my angle, 9, add it to the 53. My theorem says that 02 that I get is going to be the measure of angle BAD. Measure of angle BAD is going to be 102. Okay, then we'll go to number 2. Now makes it a little bit tricky because now I have these expressions. So now I'm not to actually find just angle A to find the other one. I actually have to use my theorems to work. What I label angle, but name for A, for angle C, and my angle B. So if I look at AC, you'll hear A. That angle is going to be 1y minus 33. ACB is my angle here at C. That is going to be 9y plus 9. Finally, my exterior angle here is going to be given by 27y minus 33. Now, if I wanted to try and y, which is my goal here, I need some sort of equation to solve for y. So what I know is that my exterior is going to equal my other two together. So that's going to be my 9y plus 9 and my 21y minus 33 added together equals 3. So I'm going to go ahead and write that over here on the side. 9y plus 9 added to 21y minus 33 has to equal y minus 33. Now I can go ahead and start to combine some terms together and figure out what's happening here. So I'm going to combine my y's on the left-hand side. 9y and 21y gives 30y. I'll also combine the 9 and the negative 3 to give me a negative 24, which is still equaling negative 27 minus 3. Then I need to try and get y's together. So I'm going to subtract 27y on both sides. On my right-hand side, my y's will cancel. 30 minus 27y is equal to 3y minus 24 is equal to negative 3. If I add the 24 to both sides then, I get 3y is equal to 21, and I can divide by 3, and I have y is equal to a 7. And that is my answer. Okay, so using my exterior angle theorem, I am able to also find y by itself and get 7. Okay? Now, that becomes a little bit trickier now when I start to talk about a quadrilateral, because we didn't have a quadrilateral theorem that dealt with exterior angles. However, I still can use it, because I know that this angle here, angles 3 and angle 4, form a linear pair, so they have to add up to be 180. So what I'm going to do is I'm going to use this quadrilateral here. I'm looking at for angles 3 and angle 4. And this question actually kind of gives away what we're going to do. We're going to find angle 3 first, then we're going to find angle 4. But to find angle 3, I have to remember that these angles in a quadrilateral sum to be 360 degrees. So I'm going to take 360, and I'm just going to go ahead and start subtracting these angles away. So I have a 90, that's my right angle, minus 102, minus 61. If I go ahead and then just quickly on a calculator find that, I now have that the measure of angle 3 is an equal 107 degrees. From there, I can then use that to find angle 4. So I know that the measure of angle 4 is going to be 180 minus that 107. And again, I can do that quickly on a calculator. The measure of angle 4 then is going to be a 73. Okay, so the measure of angle 3 here is 107. The measure of angle 4 is 73. That is it for our notes as far as exterior angles. This is one of those sections that it seems pretty straightforward, but there's lots of different little hiccups that I can throw at you as well. So be careful as you're going through homework, making sure you're reading questions carefully and doing exactly what they say.